Hello my dear students, good morning. Again we have to discuss about the calculations of oxidation states. See, I'll underline few elements here. Here I want oxidation state of sulfur. Here I want oxidation state of sulfur and sulfur here. Okay. So to have oxidation state of this particular atom, here manganese I want, here nitrogen I want, here carbon I want. To have sulfur oxidation state in these particular acids, these are all sulfur acids. Okay, in sulfur acids, to understand its oxidation state, you must know their structures actually. Here okay, no problem, directly you can calculate because it is oxide, sulfur trioxide. Oxide means I said oxygen oxidation state is -2. So here how many sulfurs are there? 1. So you can have x plus 3 into -2 is equal to, here is there any charge on SO3? No. SO3 is a neutral molecule. So equal to 0 I am considering. Then x equal to plus 6. Whereas sulfur acids, if you want, okay, us acids and ic acids, like the two types of acids we will have. Us acids and ic acids. Here I will tell you two things. Okay, sulfur us acids means sulfurous acids have structure one kind, and sulfuric acids have two structures. Us acids has a skeleton structure, S double bond O and 2 single bonds. This is the skeleton structure of us acid. Okay. Sulfuric acids has S double bond O and single bond like this you are having. This is sulfuric acids. Sir, here you written okay, us acid. Us acid, any example sir means I give you here. H2SO3. Its name sulfurous acid. Sulfurous acid. Okay. So us acid means sulfur has 4 bonds. Us means less oxidation state. Us lesser. Like that you have to remember. Okay. Here in us acids of sulfur, sulfur has 4 bonds, and in ic acids, sulfur has 6 bonds. And in that ic acid, there are 2 double bond O's. Remember, this is one S double bond O. This is one S double bond O. 2 single bonds you will have. So actually here second one, third, fourth, fifth, sixth, all are ic acid type only. Okay, except this us acids. Okay, this classification of sulfur acids we will have in second year. But now I will give you simple way how to remember sulfur acids. If they said any us acid, sulfurous acid, pyrosulfurous acid, like that they will give. Us they used means sulfur has 4 bonds. Ic they used in that name, then sulfur has 6 bonds. Okay. Now you can write these all are ic acids actually. What type of acids? Ic acids. Excuse me. In their names we have ic, sulfuric, okay, peroxysulfuric, like that, pyrosulfuric. How to convert all these and how to remember in second year, I will give you one trick, but not now. Okay, but simply remember, this is the pyrosulfuric acid, this is the peroxydisulfuric acid, like that we will remember, and I will give you their some common names also. Okay, please remember, these are all ic acids. This second one is ic acid, third and fourth, fifth and sixth are ic acids. This is ic acid ion after loss of H plus, this one. This H2SO3 is us acid. Its name I written sulfurous acid. Okay, I'll start with us acid here. See, here what I written? Us, sulfurous. So S has 2 bonds. Oh, sorry, 1 double bond O and 2 single bonds like this. This is the skeleton structure. There are 3 oxygens. 1 oxygen as S double bond O, means remaining 2 oxygens you have here, OH and OH. I told you, do you remember or not? Oxygen in the form of double bond O or OH, oxidation state is -2, I said. Do you remember or not? So here oxygen has -2. This oxygen -2, this oxygen -2. So that I can take it as X plus, there are 3 oxygens, 3 into -2, there are 2 hydrogens, 2 into +1 is equal to 0, then X means you are having +4 here. X you are having what? +4. Remember this one. I repeat, sulfur oxidation state I want here. Sulfur I am taking X, there are 3 oxygens. All 3 oxygens are as a double bond O or else OH. In these kind of bonds, oxygen has -2, I said. Okay, so here oxygen is -2, here oxygen -2, -2. 2 hydrogens, hydrogen with non-metal I said +1. So hydrogen +1, hydrogen +1. So 2 hydrogens are there. 2 into +1 equal to 0. Then X equal to +4 you are having. This is the what we call oxidation state of sulfur in H2SO3. But let's consider this example H2SO4. Now what is the structure of this? What is the structure of this H2SO4? Let's see. So it's a sulfuric acid. What it is? This acid is sulfuric acid. As of we know, ic acid. Ic acid means what is the skeleton structure I said? Double bond O, 2 single bonds. So as I said, S double bond O, 2 oxygens over, total 4 oxygens, and the remaining oxygens are always in the form of OH. Remember this. So now what will be the oxidation state of this sulfur? X plus, there are 4 oxygens, 4 into -2, 2 hydrogens, 2 into +1 equal to 0 I have to take. Why equal to 0 I have to take? Because here this is a neutral molecule, so no charge on this molecule, so equal to 0. Then X, what I'll get? +6. See, plus more oxidation state. Here less oxidation state. So in that way also you can say this is us acid and this is ic acid. From the oxidation state also you can say whether that is us acid or ic acid actually. Okay, come to this. This H2SO5, this is peroxysulfuric acid or else Carros acid. What is this? Carros acid. Here if you write without writing structure, if you calculate, in this way you will calculate X plus, there are 5 oxygens, 5 into -2 plus 2 into +1 is equal to 0. Then X minus 10 plus 2 is equals to 0. X equals to +8 you will get. But it is absolutely wrong. You only can come to know whether this is wrong or right. This is absolutely wrong. Do you know how I said? I know structure, that's why I said no. Why I said sulfur is a 6th group. Its maximum oxidation state is a group number. Maximum oxidation state of sulfur is a group number. Sulfur group number is what? 6. So maximum should be +6 only. More than +6 not possible for sulfur. So +8 you got means this is wrong. So what you did is wrong. Then what I have to do, sir? Its structure is like this. S double bond O, and you have OH and you have OOH. This is the skeleton structure. Okay, S double bond O. Actually sulfuric acid means OH and OH, but one more oxygen as a peroxy bond, OOH. Means what bond that is called? Peroxy bond. So that what will be the oxidation state? X plus, there are 2 oxygens and this oxygen also single bonded. So 3 into -2 plus 2 oxygens, 2 into -1 and 2 into +1 is equal to 0. This is the structure. This is what? Structure. S double bond O, OOH and OH. So this oxygen -2, I will write oxidation state. This oxygen -2, this oxygen -2, this oxygen minus 2. So 3 oxygens are minus 2. So 3 into minus 2. 2 oxygens, this is minus 1 and this is minus 1. So 2 oxygens minus 1. 2 hydrogen. Hydrogen is always plus 1 with non-metal. I told you already. So 2 into plus 1 equal to 0. Sir, this is not oxygen, sir. Equal to 0 I took. Equal to 0. 0. Okay. Then what will be the oxidation state? X minus 6 minus 2 plus 2 is equal to 0. Then X equal to plus 6 only you got. What is the oxidation state you got? Plus 6. So in Carros acid, sulfur oxidation state is plus 6. Please write down this sulfur acid. I will write one more way clearly. Okay. Sulfur acid skeleton structure you write down first. S double bond O, so that I will write very clearly this one. Okay. So sulfur acid you written suppose. Now what is the Carros acid structure? S double bond O, double bond O. These all are weak acid types. Remember all this. And one oxygen as OH. And if it is OH, sulfuric acid. So one more oxygen is there. That's why OOH. Got it clearly? So O single bond O if there, that is called peroxy I said. So this one minus 1, this one minus 1. This oxygen is minus 2, this oxygen minus 2, this oxygen minus 2. Hydrogens plus 1 and plus 1 actually. So if you add all these, you will get oxidation state actually. Sulfur oxidation state I want, I'll add, let's see. Minus 2, minus 2, minus 2. Minus 6, minus 7, minus 8, minus 8 plus 2, minus 6. That means X minus 6 is 0, then X equal to plus 6. No sir, like this confusion means I written already. Like that also you can calculate. Got it everyone? So here it's very clear. So here you can write oxidation state now for this. Structure I hope you understood. These are all weak acids, Carros acid. Otherwise this is also called peroxysulfuric acid. Remember and write down peroxysulfuric acid. So X plus sulfur oxidation state X, and there are 3 oxygens as minus 2. So 3 into minus 2, 2 into minus 1, 2 into plus 1 is equal to 0. Then X equal to plus 6 you are having. Understood sir? So this is oxidation state of H2SO5. See here sulfur has 6 bonds or not? Let's see. Double bond O, double bond. This is the skeleton structure of weak acid. Double bond O, double bond O. Single bond O and single bond. 2 single bonds like this and 2 double bond O's like this. Remaining are oxygens only you have, those we will write. Hydrogens, remember, sir, hydrogen won't directly attach it to sulfur, you may ask. Hydrogens always try to attach with most electronegative atom. So here sulfur and oxygen. Who is more electronegative? Oxygen. So with oxygen only hydrogens remains. Got it sir everyone? So this is about weak acid. This is also write down so that I will erase this weak acid. So you write down all 10 examples, but before that I will calculate one by one now. So what is H2S2O7? Whether this has peroxy bond or not, let's see. So first write down structure. S double bond O and double bond O. S double bond O and double bond O. Its name as is oleum actually. Oleum. O-L-I-U-M. Okay. Or pyrosulfuric acid. I written like this, but I have here one more bond like this. So here one more bond like this, because weak acid has 6 bonds I said. 2 double bond O's and 2 single bonds like this. So now I have total, each sulfur has 6 bonds. Okay, fine. So 2 oxygens and 2 oxygens. Total 4 oxygens are written. Remaining 3 oxygens, right? Because O7. Understanding everyone? So here you have 1 oxygen. So here 1 oxygen. 1 oxygen remaining, where I have to write? I don't have any other choice. I have to write in middle like this. This is called pyro. What this is as? Oleum or else pyrosulfuric acid. Okay. So now hydrogens are with this. Hope you can write now. This is the structure. So that, sir, this is not O bond. Don't think this is peroxy bond. Remember, peroxy bond means 2 oxygens should be present. Okay. So this oxygen you have to consider as normal oxygen only. Got it, sir, everyone? So here, how to calculate oxidation state of this sulfur now? So each oxygen is in normal oxygen bond only. So how to write now? How to write its oxidation state? How many sulfurs are there? 2 sulfurs. So 2x. Understanding, everyone? So every oxygen is in oxide form only. It is not in peroxy form. Because here each oxygen is in either double bond O or else OH. Sir, oxygen is single bonded. No, you may ask. But single bonded 2 oxygens should be present. Then only those 2 oxygens have -1 charge. Then only those oxygens we can consider as peroxy. Remember this one. So 2x plus 7 into -2 I can consider, because 7 oxygens. All 7 oxygens has -2 and 2 hydrogens are +1 equal to 0. Then 2x equal to -14 and +2 means 12. Plus 12 I will have, and x equal to +6. This is the oxidation state of Mr. H2S2O7. Next one is fifth. What I said? H2S2O8. This is called peroxy disulfuric acid or else Marshall's acid. What acid this is called? Marshall's acid. Very simple. As it is H2S2O7 you write down here. And just one more oxygen you write here. That's it, enough. Then what you will get? S double bond O, OH and O, S double bond O, OH. Or now here you have a peroxy bond. O, single bond O. That's it. See the difference? H2. See, all are equal, you can say. See, sulfur has how many bonds? 1, 2, 3, 4, 5, 6 bonds. 6 bonds sulfur if have, that is ic acid. Sulfur if have 4 bonds, that is us acid. In 4 bonds, one is double bond O, 2 are single bond O's. But in ic acids, 2 double bond O's and 2 single bonds. Remember this. And 2 oxygens has -1 and -1 charge. Because this is called peroxy bond again. Because O single bond O you have. Understood, everyone? So that here what I can write? I can write 2x because 2 sulfurs are there. Correct or not? Yes, 2 sulfurs. And how many are in oxide bond? 1, 2, 3, 4, 5, 6. So 6 into -2. 2 oxygens are in peroxy bond. So 2 into -1. These are in what bond? Peroxy. And 2 into +1 is equal to 0. That means 2x you are getting 12 and x equal to +6. If you don't know this structure, what you will do? 8 oxygens you will take, and for 8 oxygens you will take -2 only. Then 2x plus 8 into -2 plus 2 is equal to 0. Then you will get wrong. Then you will get +7 for this if you calculate like that. So that you must know structure. I told you how to write structure. Sulfur have 6 bonds here. With 4 bonds you try, you won't get this. Sir, why not this is acid? I'll write with 4 bonds. You cannot write. Because if you remove this, what about remaining 2 oxygens? You cannot remove, right? So you will have S double bond O like this, S double bond O like this. So 2 oxygens are in peroxy bond. That's why 2 into -1 you write. The remaining 6 oxygens, 1, 2, 3, 4, 5, 6. 6 into -2, we are having 2x equal to +12 and x equal to +6. Hope you understood all. Okay. So acid I written here. Remaining acids you can write normally. Whether that is acids or ic acid based on number of oxygens you can say. And whether they have peroxy bonds or not by using oxygens you can say. Hope you understood all these things. So we discussed 1, 2, 3 and 4, 5 and this one 6 and 7, 8, 9. One more I written HSO4 minus. I was not supposed to write, but now I'll write oxidation state of manganese here. Manganese is very simple. Here all 4 oxygens are in single bonds only. Mn, you are having double bond O, double bond O, double bond O, and double bond O actually. But otherwise O minus and K plus like this. Actually not required all these structures. With transition metals, oxygen as oxide only, remember. Manganese is a transition metal or not? So oxygens are in what form? Oxide form only. Oxide form means oxygen, oxidation state, we have to take -2. That's it. So here manganese I am considering X. 4 into -2. Potassium. What metal that is? Alkali metal. So it's +1, so equals 0. X minus 8 plus 1. So simply I can write X is equals to +7. Got it everyone? So now NH4 plus I can write like this. Can I erase this 10th one? H2SO3 sulfurous acid. You write down this please. Okay. Pause the video and write down. That's it. Because I have one more example, that is HSO4 minus. I'll write here. Okay. Now NH4 plus. This few people confused. That's why NH4 plus. In that nitrogen oxidation state, if they ask, that is not +1. The whole NH4 plus, the group has +1. That is a thing you have to remember. Okay. Now what is the oxidation state of nitrogen? X is equals to hydrogen with non-metal. +1 I said. X plus 4 into +1 is equal to +1 you have to take. Why you equalize to +1 sir means on the top you have +1 charge. That charge you have to mention there. So X plus 4 is equals to +1 means X is equals to -3 is the oxidation state. If I want CO3 -2 in that, what is the carbonate oxidation state means -2, but carbon oxidation state is not -2. Let's calculate what is the carbon oxidation state. X plus, this is carbonate. Here also oxygen is in normal bond only. Normal bond means oxide bond. So 3 into -2 is equal to -2. Why I equalized with -2? Here you have charge -2. So that X equals to, what you will get? Here -2, -6, here -2. X equals to +4. Understood? In this way you can have oxidation states and their structures. Please remember. So here you have SO3, H2SO4, H2SO5, carous acid or else peroxy sulfuric acid, oleum or else pyrosulfuric acid. This one Marshall's acid, and here you have KMnO4, NH4 plus and CO3 -2. Please have a screenshot everyone please. Okay. Not with me. Just take this screenshot. Okay. Now I give you one more example. That's this HSO4 minus. Here I want oxidation state of sulfur again. Very simple. Your sulfur oxidation state I will consider as X. This is H2SO4 is no peroxy bond. So here also no peroxy bond. If you want structure, it's very simple. Double bond O, double bond O. One OH, one is O minus, that's it. O minus. Because OH is there, one hydrogen gone as H plus. So remaining is O minus. So here you have OH. So if this is O minus, it's OH I'll write. No problem, you can write. Okay. So here same story, it's like sulfuric acid, one hydrogen is not there. So X I'll take, X plus 4 into -2, one hydrogen, so +1 equal to -1, that's it. So that here also I'll get +6 only, -8. So I'll get -7 here, goes here, +7, so +6 remains. So this is about oxidation state of sulfur, how to calculate in different molecules. I was given KMnO4, NH4 plus and CO3 -2. Okay, next I'll give you few more examples. Please remember all this and you try some more examples how to calculate oxidation states, because if you know oxidation states, many topics you can understand further in P block and complex compounds and D block, all those. Okay, you can understand easily. Suppose if I give an example SO4 -2 like this. Okay, and here also same story, -2 we have to take, and x plus 4 into -2 equal to -2, then x equals to +6 only you are getting. +6 if you are getting, that is weak acid. +4 like that you are getting as acid. Remember. Okay, it's not acid, it's anion actually. This is sulfate anion, sulfate. In that, what is sulfur oxidation state means you will write like that. Sir, suppose any acid with phosphorus given, sir, H3PO4 or else H3PO3 in basicity I said, do you remember or not? Phosphorus always has 5 bonds I said. Phosphorus have how many bonds? 5 bonds like this I said. Do you remember? Phosphorus have 5 bonds in any of its acid. Suppose H3PO4. Here phosphorus has 5 bonds. 5. Okay, P double bond O, 3 single bonds like this. Now if I ask oxidation state of phosphorus in H3PO3, same story. This also has phosphorus 5 bonds. Phosphorus acid, phosphoric acid, any phosphorus acid, phosphorus has 5 bonds. 5 bonds like this with 1 P double bond O. With 1 P double bond O like this. So remaining 3 oxidants, 1, 2, 3, total 4 oxidants, right? So OH, OH, OH. In normality concept I explained gram equivalent weights to calculate basicity is required. There I was explained. Simple. Here there are total 3 oxidants, H3PO3. So here 1 oxidant you have already written. So 2 oxidants only you can write. So here hydrogen remains directly. So here 2 hydrogens as OH, OH. So whatever here all oxidants are in either double bond O or else OH. I told you clearly. Oxygen as double bond O, oxygen as OH, oxygen oxidation state is -2. Got it? So phosphorus I will consider as X plus 3 into +1 plus 4 into -2. Why I am not writing peroxy like that, understood? There is no peroxy bond. Peroxy means OO. Okay, then X equals to +5. Oh, equal to 0, sorry. What I am doing? Yeah, 3 hydrogens, 3 into +1, 4 into -2. -8 plus 3, I will get +5. Here what is the oxidation state of phosphorus? X plus 3 into +1 because 3 hydrogens. Hydrogens are +1 or not? +1, +1, +1 like this. Oxygen -2, -2, -2. Total -6. -6 plus 3, -3. That means X is +3. Because X -3 remains. Understanding? Otherwise follow this. X 3 hydrogens, 3 into +1, all oxidants are in oxide form. So 3 into -2 equal to 0, then X equal to +3. So among these, who is as acid? I have a doubt. Who have less oxidation state, that is as acid. This is phosphorus acid, less oxidation state. This is weak acid, more oxidation state. Hope you understood. Otherwise, how I said without writing X, 3 hydrogens plus 3 oxidants -6 -6 plus 3 -3 X -3 0, X equals to +3. That's it. Okay, next, carbon suboxide. Carbon suboxide means C3O2. CO2 means everybody will say. CO2 means C double bond O, double bond O. -2, -2, -4. For terminal atoms, -4 means opposite charge for carbon. So +4. That's it. Very simple or not? So CO2 means everybody will say. What is the carbon oxidation state? Carbon oxidation state in C3O2, carbon suboxide. If you calculate 3x plus 2 into -2 is equals to 0, 3x equals to +4 and x equals to 4 by 3. This is wrong. Yes, wrong. So that this is exceptional example, this one. Remember, carbon suboxide. C double bond, C double bond, C double bond, O double bond, O. This is the carbon suboxide oxidation state. This central carbon has zero oxidation state because this carbon bonded with carbon, this carbon bonded with carbon. So all three are same type. Same type means what? Because there are a zero oxidation state. This adjacent is carbon. Adjacent is carbon. No exchange of electrons. Equal. So this carbon is 0. So this oxygen is -2. Double bond O means -2. This oxygen is -2. So this carbon is +2. This carbon is +2. How I said +2? Understood everyone? This carbon has +2 because oxygen is -2. Why? They should cancel because C3O2 is neutral. This oxygen -2, this carbon is +2. So why sir this carbon has +2? Why not this means? This carbon attached with a different atom. Certainly this carbon has charge. This carbon, both sides carbons only. No charge for it. So this carbon is 0 oxidation state. So this is about carbon suboxide. Next. Br3O8. This is a neat question. Bromine oxidation state they'll ask. So here also you must know structure. Okay, tribromo octoxide. Remember, tribromo, I have right name. Tribromo octoxide. Octoxide simply. Okay, so here what is the structure? Again important structure. Br, three bromines. And double bond O, 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 double bond O. Terminal bromines have 3 oxygens. So here this terminal bromine also has 3 oxygens, total 6. 2 more remains. Those 2 more here, double bond O and double bond O. So this oxygen is -2, this oxygen -2, this oxygen -2. So this bromine, what oxidation state? So that this bromine has +6. How you said sir +6? Both are bromines. Due to this bromine, no charge for this bromine. So this bromine have oxidation state only due to 3 oxygens. So this oxygen -2, this oxygen -2, this oxygen -2. 3 oxygens -2, -2, -2 means -6 total. 3 oxygens have -6 means this bromine has opposite charge +6. The charge should cancel. Now this bromine also no need to talk same thing +6. But this one, this oxygen is -2, this oxygen is -2. Due to these bromines no charge as I said already. So this bromine has +4. Remember this. The central bromine has +4. The terminal bromine has +6. They asked this question in previous. Please remember all these things are very important. Carbon suboxide and Br3O8 like this. Okay. Few more examples we will discuss in our next class and we will enter into our next concept, types of redox reactions. Afterwards, balancing of redox reactions. 2 chapters. Okay. It's a very small chapter. You can have like this. Okay. Few more examples like NH4NO2. Individually, here nitrogen oxidation state I want. If nitrogen oxidation state I want means what I will take? 2x. 2 nitrogens are there. 2x I will take. How many hydrogens are there? 4. So 4 into +1. And how many oxygens are there? 2. So 2 into -2 is equal to 0. That means 2x equal to 2x plus 4 minus 4 equal to 0. Then x equal to 0. So average oxidation state of nitrogen you are getting 0 here in NH4NO2. See here also sir, this is oxide or peroxide? Nitrogen with oxide only. Remember this one. I said transition metal with oxygen. Only oxide. -2 you have to consider. Here also -2 you have to consider with nitrogen. Remember and note down all those things. But individually, here nitrogen what charge, here nitrogen what oxidation state, means you have to separate this NH4NO2. I repeat, NH4NO2 overall, or this is average oxidation state of nitrogen, means 0. But individually, what is the nitrogen oxidation state, means you have to write. Please write it down, SO4 minus 2. Pause the video and write. Okay. Now, I will calculate what is the nitrogen oxidation state in individual. NH4NO2 means it is like ionic. NH4 plus and NO2 minus. So, individual 2 ions you have to consider, as one is NH4 plus and one is NO2 minus. 2 ions you have to consider, otherwise average nitrogen oxidation state means, as I said, 0. But in NH4 plus, nitrogen oxidation state different. In NO2 minus, nitrogen oxidation state is different. Now, what is the nitrogen oxidation state, means you have to consider X plus 4 into minus 1 equal to plus 1, then X equal to plus 3. Then here nitrogen means X plus 2 into minus 2 is equal to minus 1. What I am doing, understanding? Oxygen is an oxide form here with nitrogen. Remember, write down that clearly. So, oxygen has minus 2. X plus 2 into minus 2 is equals to minus 1. Why minus 1? Charge minus 1. Then X equal to plus. Here plus 1. Sorry. X plus 4 into plus 1 is equals to plus 1. Then X is equals to minus 3 here. Then X equal to here plus 3 here. See, nitrogens have opposite charge. In NH4 plus, nitrogen is minus 3. In NO2 minus, nitrogen is plus 3. Minus 3 plus 3, 0. Overall 0 I told, or not in previous. That is the reason I said. So why sir like this? Nitrogen and oxygen. Nitrogen is less electronegative. Oxygen is more electronegative. So nitrogen has positive charge here. Here hydrogen is 2.1 electronegativity. Nitrogen is 3. 3 only. Sorry. So nitrogen 3. So nitrogen is more electronegative. So nitrogen oxidation state here minus 3. So overall is 0. But individual nitrogen's oxidation state means minus 3 and plus 3. So 3 options given, sir. Minus 3, plus 3, 0, sir. What is the option, sir? All if they given, all. And nitrogen's oxidation statements. Otherwise, average oxidation state if they ask, even minus 3 and plus 3 is there, 0 you have to take, average oxidation state means. But in NH4 plus nitrogen oxidation state means minus 3, and in NO2 minus means nitrogen oxidation state is plus 3, like that. 1 or 2 examples in our next class I will tell you, and I will continue with the new concept.